So let's go through some of these questions. The substrate for amylase. That was one of the questions in the video that we watched. Is it maltose, starch, carbohydrates in general, maltose and starch, starch and carbohydrates? Right, remember our amylase breaks some starch. So which of the following is true about enzymes? Do they become part of the product? Are they used up in the reaction? Can their activity be affected by temperature and pH? Or do they slow down the rate of the reaction? Yeah, you got it, Andrew. Right, affected by temperature and pH. So the iodine, does iodine test for starch, maltose, glucose, or protein? Yep, that was starch. Now here's a question about kind of experiments in general. Most experiments will have a control group, right? So which of these is not true about control groups? With a negative control, a negative result is expected. With a positive control, a positive result is expected. A positive result with a negative control means that we have some sort of contamination. A negative result with a positive control is required to validate the test. What do you think there, guys? What do we do? We didn't really talk about positive and negative controls, but based on what those terms usually mean, what do you think the answer is? Everybody agree with Andrew? Choice number 3? Yeah, good job. Okay. If you're expecting a reaction to occur, then that's a positive control. If you're expecting a reaction not to occur, that's a negative control. And if you get some sort of positive reaction when you are expecting a negative reaction, that could potentially indicate some contamination or a control that's not functioning properly. When we break down starches, what was the end result? Gotta think back to the video. So is it amylase? All right, no, amylase is that's our enzyme, right? ASE, right? Whenever you have ASE at the end, that's the enzyme, and OSE is a sugar. So yeah, maltose is definitely what we're going to get. So the enzymatic reaction that we are going to watch happen here with the starches is called a hydrolysis. Lysis meaning splitting. So hydrolase enzymes like amylase are breaking down large molecules into a smaller molecule, into their sort of subunits, their building blocks, through the addition of which molecule do you think? Acid, water, salt, or base? Considering the prefix there is hydro. Yeah, right, you got it, right? Hydro meaning water. Good job. All right. So this is our little setup here. You can see here's our little test tubes. We're going to put them in our incubator. This is our incubator right here. We're going to add several different and test several different solutions. So there's our enzyme, amylase. Here's our substrate, starch. We also have some maltose, one of those sort of end products. We also have some DI water, and then some solutions at several different pHs, a pH 2, a pH 7, and a pH 9. So we're going to look at how pH affects the activity of the amylase, and you'll also see we have a little boil and we have a little freeze button. So we're also going to investigate how boiling and freezing will affect our enzymes. So I'm just going to click through it here. See, we're adding in our test tubes. All right, then I'm going to add my substances. So let's see. Tube 1 gets amylase and starch and pH 7. Tube 2 gets amylase, starch, and pH 7. Tube 3, amylase, starch, pH 7. So tube 4 gets amylase, DI water, and pH 7. Tube 5, DI water, starch, pH 7. Tube 6 gets DI water, maltose, pH 7. And then 7 gets our amylase, starch, and pH 2. Okay. So we see tube number 1, right? That's going to be our control. Tubes number 2 and 3, one of them we're going to boil, one of them we're going to freeze. We're going to see how that affects it. Tube 4 had amylase but no starch in it. Tube 5 had starch in it but no amylase, so no enzyme. Tube 6 has our has the maltose in it, so the end products, and then tubes 7 and 8 have the enzyme, the substrate, but at 2 different pHs. So does that, everybody okay with where we are? Okay. So we're going to incubate our, oh, I missed something. I missed something. I'm going to go back for a second. I must have missed something. Tube amylase. Okay. So we're going to incubate our test tube. Okay, we're going to boil number 1. Okay, we're going to incubate test tube number 2. Okay. We're going to freeze test tube number 2. All right, so now we're going to incubate all our samples. What the test tube rack is going to do is sort of gently shake them, and this would normally take 60 minutes in real life, but we're going to compress it down into about 10 seconds. All right, so our cabinet doors have opened. You can see we've got our 2 reagents, our Benedict's reagents. That's the one that's blue in the presence of the small sugars. And then the iodine, that is that blue-black in the presence of starch. So here's a predict question for you guys. What effect do you think boiling and freezing will have on the activity of this particular enzyme? You think both are going to increase the activity, both are going to decrease the activity? Boiling will decrease the activity, but freezing will not have any effect. Boiling will decrease activity, but freezing will increase the activity. What do you think there, guys? Go home, baby bear. So we think boiling will decrease and freezing will increase. Brandon thinks boiling will decrease and freezing will have no effect. All right, so I think the consensus there is 4, so we shall see. All right, so we'll see how our prediction came true or not. All right, so I'm gonna pour a little bit of our sample that we boiled into the test tube, and then it's gonna pour a little bit into the test tube so we can test all of them. So now I'm going to apply some of our iodine reagent into our test tubes, and we're going to see what happens. What'd you guys notice? What happened to the color of our samples? Did they change? Okay, remember, blue-black indicates presence of starch. If it still sort of looks like the same color, the orangey color as the iodine, then that's a negative starch test. So in which tubes do we still have starch? Where do we see the blue-black color? Right? You still see that black color in 1, 5, 7, and 8. You got it. Good job, guys. Right? That nice black color. That indicates the presence of starch still. All right, so here's another question for you guys. Tube 2, which was the amylase, the starch, seems to have the same reaction as tube 3. Tube 2 was the one that we froze. Tube 3 was sort of our control. So why do you think that the amount of starch digested in the frozen tube looks to be roughly the same amount of starch as the control that we didn't do anything to? So did freezing have an effect on the enzyme? Did it denature the enzyme? Is the enzyme amylase more active at a freezing temperature? Or did the freezing itself digest the starch? So most of you guys are saying that freezing had no effect. Good job. Was that our prediction? I don't remember what our prediction was. Was our prediction right? All right, now we're going to apply the Benedict's reagent. This is going to test for the presence of the small sugars, so the presence of the maltose. So now we're adding the Benedict's reagent. All right, now we're going to boil it. See all the little bubbles coming out as it boils? Ooh, what happened to our tubes? Changed color.